Hello, Mr. G here in the G Lab. A basic law that you must obey is a law of physics and chemistry that says in any chemical reaction, mass is conserved. In other words, matter cannot be created nor destroyed. It simply has its atoms rearranged. And therefore, we need to balance our equations to make sure that they are balanced on both sides of the equation. So let's take a look at how to do that. First step is to count up the number of each type of element you have on each side of the equation. So on the reactant side, magnesium, we have one magnesium atom over here, two oxygen atoms because we've got two in the subscript. All right, and when you combine those together like we have in class and create that incredibly bright light, and then we produce a new compound called magnesium oxide. How many magnesiums over here? Well, we just have one. And how many oxygens? We just have one. Okay, so that's pretty simple. The next step is then to look and see what is not balanced about this equation. Magnesium looks good. It's got one on both sides of the arrow, but oxygen is not balanced. So go to the side of the equation that has the lower number of that one that's not balanced and figure out, hey, how can we raise this up to a 2? Well, we know that we cannot put a 2 right here because that completely changes this, and it's not magnesium oxide anymore. It's a different compound altogether. So we can't just simply change the can't simply just change the subscript. We need to put in a new coefficient, the big number here. So let's put a 2 in here and see what that does to how many oxygens we have. Well, it does a couple of things. The next thing we need to do is go, okay, well, we now have 2 magnesium oxide atoms. In other words, we've got now 2 magnesiums. So let's cross that out and put a 2. And we have 2 oxygen atoms. Okay, so 2 oxygen atoms is what we were looking for. And now look at this, our oxygens are balanced, 2 on each side, but magnesium not balanced. Now that's a problem. So we've got to go figure out, start over in a sense, and go, what can we do to make this get up to 2? Well, that's a pretty simple solution. Again, all you've got to do is put a coefficient in front of the magnesium molecule over here, and there you go. Boom. This now becomes 2 magnesiums on this side. We still have 2 magnesiums on this side, and we are balanced completely. Awesome. We're done. Now we could put a 1 here to show that there's only one oxygen molecule here, but in general we don't bother with that. If it's a 1, we just kind of leave it as a blank. We just assume that it's there. Okay, let's try another one. Here's carbon and hydrogen coming together to produce methane gas. So start with what? Here's what I'm going to recommend is that you pause the video and try this on your own first, and then restart and check and see how you did. Okay, so here we go. Count up what we have on each side. We have 1 carbon atom over here, and we have 2 hydrogen atoms over here on the reactant side. On the product side, we have 1 carbon and 4 hydrogens. So we are not balanced. Where are we off balance? Well, this hydrogen over here needs to be 4 if we're going to have balance. So what can we do to get the hydrogen up to 4? We can't just change this number here. We've got to do something to double the number of hydrogen atoms. Well, if we put a 2 in front of here, we now have 2 molecules of hydrogen. Think of this as having a H2 molecule looks something like this. A couple of little hydrogen atoms stuck together. If we have 2 of those molecules, now it looks like that. How many hydrogens do we have all together? 4. So cross this out. 4. And hey, we're balanced. That is an easy one. Simple. Let's keep going. Try this one on your own first. Pause the video and then restart when you're ready to check your answer. All right, here we go. Magnesium 1 on this side. Chlorine 1 on this side. Hydrogen 1 on this side, 1 of everything. Over here we've got 1 magnesium, 2 chlorine, and 2 hydrogen. Excuse my numbers because I'm trying to write with a mouse. All right, so we can either start with chlorine or hydrogen. Either one's fine. Just try and balance this thing out. Let's go ahead and start with hydrogen since it's kind of over here by itself. Actually, it doesn't really matter. Let's go with this. Chlorine and hydrogen, they're bigger over here, so we go to the smaller side and go, oh, let's see, what can we do to the chlorine and the hydrogen to make them 2 each? Oh, actually, there's a pretty simple solution. If you put a 2 in front of this molecule, that means you have 2 hydrogens and 2 chlorines all together. So cross these out. Again, make sure you always go through and cross out and update your new quantities. And there you have it. 2 hydrochloric acids means that you have 2 chlorines and 2 hydrogens, which now balances out your equation. Not too bad, not too bad. All right, flipping over to the back side. Sodium, which is a soft metal, combine it with chlorine, which is a toxic gas, and you put those together and you can make table salt, sodium chloride. So let's go ahead and go for it. Give this one a shot, pause the video, and come back when you're ready to check it. All right, let's check it. Yo, here we go. Sodium on this side, there's 1 of them. Chlorine, there's 2 of them. And on this side over here, 1 of each. All right, so sodium looks fine, but chlorine is off. So what do we need to do? We need to bump this up to a 2 somehow. So again, put a big 2 as the coefficient, and make sure you now update your new quantities. You now have 2 sodium and 2 chlorine. This looks familiar. This is similar to the first one we did. And what do we have? Now our sodium's off. What can we do? Put a 2 in front of this one. Boom. This becomes 2, and now you're balanced. Your sodium matches up, 2 on both sides, and your chlorine matches up, 2 on both sides. Beautiful. All right, let's do a couple more just to make sure you have it. This one here, we're going to take that same sodium, combine it with hydrochloric acid, and it'll make hydrogen and table salt. What a deal. All kinds of ways to make salt. Go ahead and try this one, balance it, and this one's a little trickier, so try this one on your own first, and then pause the video. Check your answers. All right, here we go. Let's check them. Start off with quantities of how much you have of each. Looks like we have 1 of each here. And over here we have, let's see, sodium has 1, hydrogen has 2, and chlorine has 1. So, start with hydrogen. It's not balanced. Can we just cut this in half and make it all 1? Nope. That wouldn't then be a hydrogen molecule. So we got to go over here. We got to bump hydrogen up. So if we do that, here's a 2 for hydrogen. And what does that do? It changes the amount of hydrogen we have and the amount of chlorine we have. So update your quantities on both of them. Now, hydrogen's looking pretty good. We're balanced here. But chlorine's off. So we got to make chlorine work. Well, let's try and bump this chlorine up and get it up to 2. All right, well, only way I can think of is to do this. Put a big 2 as a coefficient in front of this molecule. That changes our chlorine, but it also changes our sodium. All right, well, keep going with it. Update your quantities. We now have 2 chlorines. We're good there on both sides. Hydrogen, still good. Sodium, now we're off on sodium. So what can we do? If we can get this one up to be 2 sodium, and oh, that's pretty easy. Remember, you can't add the subscript down here. You got to add it as a coefficient. 2 separate molecules, 2 separate sodium atoms here, just like so, and we now have 2 of everything on every side, and we're balanced. Here, you could put a 1 again, but in general, we just leave that as a blank, and it's understood that there's a 1 there. Okay, now, it's not always a 2. It's not always 2s and 1s. Sometimes what you end up with is something a little different, and this one's a little trickier. So let's kind of go through the thought process on this one, and this will be our final one we do together. Here we have iron and oxygen creates rust. That's right, you leave iron sitting around outside exposed to oxygen, it will rust. Water is interestingly not a part of this process. It is a catalyst. It will help speed up the process, but it's not actually a part of the process chemically. So iron, we have 1 of those on the reactant side and 2 oxygens on the reactant side. Okay, over here we have 2 irons and 3 oxygens. All right, now where do we start? Well, neither of these are balanced, so we got to just kind of pick one to start with and see what happens. So let's try this. The easiest thing to do here, I would think, would be to go, oh, let's just double the amount of iron. So double the iron. And now our iron lines up great. Awesome. Great. Okay, 2 and 2. Oxygen, however, we're off. So what do we do? Well, if you double the oxygen, you're at 4, and that doesn't work. If you triple the oxygen, let's try this. Let's try tripling the oxygen. So 3 O2 molecules. What does that put us at? That puts us up to 6. Is there a way we can get this to 6? Indeed there is. We can simply double this. So if we double this whole molecule, we have 2 iron, 2 times 2, so that is going to be a total of 4, and 2 times 3, because you've got 3 oxygens per molecule and 2 molecules for a total of 6. Aha! So we've got our oxygen now balanced out. That was kind of a tricky one. But now our iron's a little bit off. So what do we need to do here? If we need 4 irons over on this side, we're going to need to actually go back and realize, maybe that wasn't the best idea. That didn't work so good. What do we need to do? We need to use a 4 over here and go like this. 4 irons over here, and now we're balanced out. Let's do a quick double check. Always good to double check. 4 irons on this side. 2 times 2 is 4 irons on this side. Over here you've got 3 times 2 for the oxygens of 6, and over here 2 times 3 for the oxygens of 6. Balanced out. We're good to go. Alright, remember, matter cannot be created nor destroyed. The atoms just get rearranged. Therefore, we need to balance those equations.